And we are back. Here it is, the moment you've all been waiting for. I am about to go through the chemistry section of Unit 1. So for those re-sitting Year 11s and those Year 10s that are about to sit it for the first time, here is the game changer. This is where we are going to make dreams happen, okay? On we go, straight into the chemistry paper. Straight away, here we have it. This question is about paints, okay? You might be thinking, wow, it's as interesting as paint drying. No, it's not. It's much more interesting than that, okay? So paint contains a mixture of pigment particles dispersed in a liquid. What is the name of this type of mixture? So again, it's higher tier, so it is a bit tricky, but you should remember it is a colloid. And there's our first mark. How easy, how quick, all done, move it on. Look at the pie chart showing the ingredients in two types of paint, A and B. Which paint would you expect to dry faster? Right, so first thing you need to think about is how does paint dry? And if you remember, paint dries when the solvent evaporates, then you should think, right, the paint that's going to dry quicker is obviously A, okay? You don't actually get any marks for saying A. What you get your marks for is explaining it. So the first mark is worth for solvent evaporates. So if you say, because when paint dries, the solvent evaporates, and then if you say that A has got less solvent, then it'll dry quicker. There's your marks, okay? 3 really easy marks at the start of this paper. And so yeah, we're off to a really good, strong start. Here we go. Duncan is using the internet to find out about alkanes. Alkanes are hydrocarbons found in crude oil. Duncan plots the data for propane and butane on the graph. So here he is, okay? The first mark for this question is on the other page, and it is to add the next 2 data points. So they've done propane and butane. There's propane and butane. We need to do hexane and heptane. So you mark your graph. You need to look at 6 carbon atoms. Just highlight it, and 69 degrees, okay? So down we go, we have a little look, there's the 6 carbon atoms, we're looking for 69 degrees, so 60's by here, and we're looking up from that. We go to find them in the middle. You have to forgive me for my inaccuracies on my graph, that's about 70, it should go down a bit, but it's a bit difficult on the iPad, okay? And then you add your next data point as well. So you need to do 7 and 98. So again, we look along the bottom, remember, well, there's 8, 7 is here, halfway along, so we need to do 7 with 98, so we go all the way up to 90, then 100's there, so we give a little mark at 98, and that's our first mark available. The second mark, again on the other page, is where they say that Duncan couldn't find any data for a hydrocarbon that's got 5 carbon atoms in it, okay, so 5 carbon atoms, and you have to estimate how high its boiling point is going to be. So basically what we've got to do is we've got to kind of draw a little trend line on here. So you can see that our first point's down here, and here's all our points, and so if we can draw a bit of a straight line going through them all, we can get a really good idea of what our boiling point for 5 hydrocarbons is. So it's come out at 32 there. So the mark scheme will actually allow you between 26 and 36. So you go from all the way down here up to here. As long as your line comes in this kind of area, then you're going to get your marks. Right, so like we said, there's our first 2 marks. We've got our first mark up here for plotting the graph. Our second mark down here, like I said, between 26 and 36 will get you the mark. We worked it out to be 32 degrees C. So using ideas about forces between molecules, explain the trend in boiling points of the alkanes. So again, because it's higher tier, they're trying to make it a little bit difficult. They're not even telling you what the trend is. As we can see from our graph, if we think back to what our graph looked like, we had a line going up here. So we know that as our number of carbons is increasing, our boiling point is increasing. So our first mark is available for just saying that. So if we said as the number of carbons increases, so carbons increase, therefore boiling point increases, that's 1 mark there, okay? Our second mark comes from the explanation. So you need to have a little look. So explain the trends in the boiling points. So how can we explain that? We can say that the more carbon atoms, so the more carbon atoms, then the stronger the intermolecular bonds. So remember, intermolecular means, I always remember it by international. So if it's an international match, it's between two nations, two different countries. Intermolecular means that it's forces between two molecules, okay? So intermolecular, international, try and remember that. On to the next question. So butane, C4H10, burns in oxygen. Carbon dioxide and water are made. Write the balance symbol equation for this. So as I said in the Unit 3 video, when you write a balanced symbol equation, there's always going to be 2 marks available. Now these 2 marks, you get 1 mark for writing the equation correctly. The second mark is for balancing it. So don't panic when you see this thing, because you can pick up a really easy mark just by using what they've told you in the question. You know this, butane, reacts with oxygen, and then we get carbon dioxide and water out the other side. If you just write that down as a symbol equation, then you get a mark. So let's just do that quick first off. So we've got C4H10 plus O2 gives us carbon dioxide, which is of course CO2, and water, H2O. If you just get that far, that is a mark, okay? You don't even have to attempt balancing it, and you get yourself a mark. Now to balance it, we're always looking at what have we got on either side of the equation, and how can we balance it out. It's a really tricky balance. Have a little go at it. I'll just give the answer. So the balance is that we have 2 C4H10s, we have 13 O2s, we have 8 CO2s, and we have 10 H2Os. If you put all that down, then you get the second mark, okay? If you can balance them easily, then go for it. If you're struggling with balancing a little bit, maybe just be happy with the 1 mark and move it on. Some of the fractions from crude oil are cracked, okay? Look at the table. It gives information about some of these fractions. Suggest why molecules on the naphtha fraction are cracked. Use information from the table. So what we should be thinking about here is cracking. Why do we do cracking? Why do we crack some fractions of crude oil? Now, the reason we do it is always supply and demand. So let's have a look at the table. We can see that everything up here, so naphtha and paraffin, have both got more being made than is needed. Whereas down here, petrol and LPG, we're not making enough of it. So essentially, if you put that down in your answer, then you get your 2 marks. So the first mark is that the idea that naphtha or paraffin is in excess. So a higher percentage found than needed. Okay. Your second mark is for saying that naphtha can be converted into LPG or petrol, which is in greater demand. Yeah, you can see that petrol, we only get 8%, but we need 22%. And that's how it works. On to the next page. So straight into another graph. Nitrogen dioxide is a pollutant found in air. Scientists think that there is a link between nitrogen dioxide levels and the severity of asthma attacks. Look at the graph. It shows data about the severity of asthma attacks in young men. Okay, so we can see there's a pattern in those graphs. What conclusion can you draw about the link between nitrogen dioxide levels and the severity of asthma attacks? Really easy mark. What's happening as nitrogen dioxide is going up there? What's happening to the severity of asthma attacks? Well, obviously, that is going up as well. So if you say that as nitrogen dioxide levels go up. The severity of asthma attacks also goes up. And there you go. First easy mark. So, the data is for men aged between 20 and 40 who live in a city centre. Nick thinks you can use the graph to draw a firm conclusion about nitrogen dioxide levels and the severity of asthma attacks. Phil thinks more evidence is needed. Suggest who is correct and explain your answer. So clearly, Phil is right here. But you don't get a mark for just saying Phil. You need to explain it. So why is Phil right? So you could say that the data doesn't include children, old men, or women. You could say that you need to use different age groups. You need to use different genders. You need to say that the research doesn't consider lifestyle. The idea that the data doesn't include people who live in the country. All these different things will get you that mark. All right? So Phil's correct. You could say different age groups required. Needed. Lovely. 2 fairly simple marks there, guys. So, here we have it. Sue prepares a meal. She cooks some meat. Sue notices that the texture of the meat changes when it is cooked. Explain why the texture of the meat changes. It's a really straightforward answer. It's simply because the shape of the protein changes. You could also say that the protein denatures, but you don't need to go into that much detail. So Sue serves mayonnaise in the meal. The mayonnaise contains an emulsifier to stop the oil and water from separating. Using a labeled diagram, explain how an emulsifier stops oil and water from separating. Essentially, what you need for this diagram, okay, is you need to have something that looks a little bit like that, okay? You know my drawing's not fantastic, but we can live with that. So we've got a hydrophilic head, and we've got a hydrophobic tail. All right, lovely. You should remember that the hydrophilic head loves water. So there's our water molecules. And then you should also remember that the tail, hydrophobic tail, hates water, so it's going to attach to the oil. Now, that diagram will actually get you the 2 marks because you have shown that the hydrophilic head loves water and bonds to water, and you've shown that the hydrophobic tail bonds to the oil. And so that means that it allows it to mix, okay? So the philic head and the phobic tail allow the oil and water to mix because they kind of bridge the gap between them. Brilliant. On to the next page. This question is about carbon compounds, okay? Look at the displayed formulas of some compounds. So they always put in a question like this because they want to test how well you understand what a carbon compound is. Let's have a little look at the actual question itself. Compounds A and C are hydrocarbons. Explain why. Okay, so if you put contains carbon and hydrogen, you only get 1 mark. If you put just 1 extra word, only contains carbon and hydrogen, then you get your 2 marks. It's literally that simple just to get that extra mark there. Which compound will be decolorized by bromine water? Then you should remember compounds with a double bond in them will decolorize bromine water, so it's C. Last question for the chemistry. It's a 6 marker. Bit tricky to finish on, but let's have a little look at it. So what I'll do, just like the other 6 mark question, I will let you have a little think about it, let you have a little go at it, and then I'll show you the mark scheme for it. So look at the displayed formula for propene. Propene molecules can join together to form polypropene. Describe and explain how propene molecules join together, include an equation and the structure of the polymer in your answer. Okay, so there's a couple of different parts to it. We need to describe and explain how propene molecules join together, but we need to include an equation and the structure of the polymer. So take a minute, write down some notes, and we'll look at the mark scheme in a sec. So pause me now. Good, so well done. Let's have a little look at the mark scheme. So just as the other 6 marker, we've got level 3, level 2, and level 1. We'll focus mainly on level 2 and 3 because that's where the majority of our marks are, 3 to 4 or 5 to 6 marks. If we have a little look, we can see that level 2, basically to get level 3 we need to do everything in level 2 and a little bit more. So you need to apply knowledge of polymerization to draw the displayed formula of polypropene, or give a complete description of polymerization to make polypropene and give a condition. The extension bit for the level 3 answer includes an equation for the polymerization of polypropene to make propene to make polypropene. So if we have a little look at what it's actually asking us to do, here it is. That is the equation they're looking for. As you can see over here, we've got propene with a double bond in the middle. This N just simply tells us that we've got lots of them. It's just a number, it can be. Over here, it's gone to a single bond, but we've got these bonds out the sides, which shows us that it is a polymer now. This N is telling us how long the chain will be. So, as you can see, the double bonds moved out, and we've got these things on the outside, which shows we've got a polymer. There's our equation. The other things they're looking for are down here. All right? They are looking for the idea that that propene is an alkene, the idea that propene is a monomer for the polymer. Okay, remember alkenes are the hydrocarbons with a double bond in the middle, and they're the only ones that become polymers because they're the only ones that these bonds can come out. So this double bond has come out to form these. The idea that propene is unsaturated and there's double bonds. You can say that many alkene molecules react together to form a polymer. Okay, so there's loads of different things you can have here. What they also want is the conditions needed, and that is high pressure and a catalyst. So quite a lot that you need to remember, but it's not a particularly challenging question there. So I'm hoping that lots of you would have gone, maybe not have gotten this equation up here, but lots of you should have gotten these things down here, and that would have been a level 2 answer, getting you 3 to 4 marks. Right, I hope you've enjoyed that, guys. It's taken me a while to do it, and yeah, like I said at the start, this is going to make the difference in those grades. Yeah, listen to these videos, think about them. If you want to have this past paper to actually go through whilst I'm talking to you, then just ask, and we can print you them out, and you can go through them at the same time. Hope you've enjoyed it. Hope it's useful. Stay tuned, and we're going to get the physics paper up there, okay? And remember, as always, stay classy, guys.